All right, stretches. Stretches is like pulling or squashing the function. All right, so again, just like last time, we will have some example here. So we have the fx equals to x plus 2, or y equals to x plus 2 if you want it. And then I got 3 type again here. So I have 3fx, half fx, and 5fx to make it easier. So again, we just put in the function 3 times x plus 2. So we have 1 over 2 x plus 2, and we have 5x plus 2. Because I'm too lazy to get into the simplest form, so what I'll do is I just plug in the calculator. So there we go. So first one, I have x plus 2, and then I have 3 bracket x plus 2. Oh, I love GDC. 0.5 x plus 2 and 5 x plus 2. Alright, so if we sketch that, you can see that, when the x is the same, but it have been squashed. From the blue one originally go on that way, it have been squashed down, keeping the x is the same, keeping the y is the same, at the same place, but it have been squashed inwards. Alright, originally it's 3 here, 1, 3, and then it have been squashed. It has been squashed horizontally, so it's squishy here, and then it's squashed like that, a vertical. Alright, so we'll say that if it's multiplied outside, it will be vertically squashed, while keeping x the same, and y will be squashed. And if x is bigger than 1, it will be further away. Multiply it 3 here. The green one is further away from the further away from the x-axis. Alright, so originally here, and then it's multiplied down there. Alright, so it's the original 1, and then become 3 here, from 1 to 3. And then if it's by half, it's originally here, and then it's gone to half. Alright, so I can say that, I can summarize it. It is a vertically stretched. And if for y equals to p fx, which is we change the fx by, multiply fx by a number, when p is bigger than 1, then it will move further away from x-axis, which means that it has been pulled down upwards, vertically stretched down that way. Alright, so vertically stretched. And when p is smaller than 1, but bigger than 0, because it's multiplied by 0, it doesn't work. Alright, then it will get closer to the x-axis, which means that it go on that direction. Let's try the horizontal stretch. Now we have multiplying y equals to, maybe we stuck with fx. Alright, now we have fx equals to x squared. If I have changing it to 2x, 3x, and half x, what am I doing? So now we have 2x all square, 3x all square, and 0.5x all square. So now we have the calculator again. X squared, 2x squared, 3x squared, and which one? 0.5, oh sorry, quick bracket, 0.5 x squared. And remember, the original one is blue, and the red one is multiplied by 2. And you can see that the blue one, the bigger the number we multiply it, is squashed, horizontally squashed by by the factor of it. All right, the bigger the number is, the more we squash it, and the smaller the number is, the more we stretch it horizontally. So we can summarize it like this. When for it equals to qx, it is actually stretched with a factor of 1 over q. Multiply it will be 1 over, it's just squashed by half. It's multiplied by 2, it's squashed by half times. So we can summarize, we can further elaborate it, become like this. If q bigger than 1, which means that at y equals to fqx will be closer to the x-axis because it got skinnier. Sorry, closer to y-axis because you're squashing it. All right, so the symbol should be like that. We are squashing it. All right, if q is a fraction or decimal number, so it's bigger, not equal to 0, don't multiply it by 0. Is it smaller than 1, then is this. Then it will go further away from the y-axis, which is we pulling it apart. And this is stretches.